Hi everyone, my name is Tricia Gregg, and this is my final project for Python, which is CSCI E7. And I just wanted to share what I was working on with you today. So for this project, we had to choose something of our own to solve. And one of the issues that I deal with a lot at work is that I'm analyzing text and I need to look at word frequencies for different texts to see what's being emphasized in one year versus the other. So I usually use NVivo to do this, and it works really well to generate word clouds and other visualizations, but it's sometimes really hard to compare one word cloud to another. So I wanted to use Python to do some word frequency counts and to visualize that as a graph instead of a word count. So it might be easier to kind of compare two different documents to each other. So that's a description of the problem. I decided to solve this problem by using NLTK, which is a common library for text processing and natural language processing. And I started off by reading some of the documentation on NLTK, and I pretty quickly got lost, so I stuck to just some of the basics. And I also decided to use matplotlib based on Jeff's presentation in class. So those were the two main libraries that I used. So what I did to solve this problem was I imported everything that I needed from the library. I created a couple global variables to use. One was a list of the punctuation because I wanted to remove that from each of the documents that I was trying to analyze. A list of stop words. Stop words are commonly used words like and, the, if, is, because those are just really frequently used and don't really contribute much to the actual content of the text that I'm trying to look at. I actually didn't end up using Porter stemmer, but stemmers are algorithms that go to the root of the word, and lematizer, which is an algorithm that groups words that have the same root together. So I decided ultimately not to use Porter stemmer just because the stemmed words were really hard to read because they often weren't real words. They were just roots that didn't actually end up being real words. So I decided to use lemmatizers instead. But I have that as a remnant in my code. Okay, so the first thing I had to do was read the file. So I would open up the file, I would make everything lowercase, put it into a string, and then I would tokenize that string, which basically took all the words in the string and split them up into a list. So I would end up with a list of words at the end. Then, in order to remove stop words and any other characters, I used a list comprehension. So I only kept the words that weren't in the stop words and that were alpha characters. And then I decided to lemmatize the word in the word list, in the resulting word list, in order to get those groupings that I talked about. And then the result of some of the code that I'm going to share with you is a list of lists. So I wanted to get to the interior list, and this is some code that helps me do that. And then I take in arguments from a file. I try opening them. So I try reading them. I try removing any of the stop words and any of the punctuation. I try to lemmatize them and then count them. And then I look at the 10 most common in each. And from there, I find the keys and the values. And then I'm going to plot them. And so what happens when we run this is I'll go to edit configurations. I'll add in 2 text files that I have, and then I'll run, and we'll have to wait a little bit until the plot is generated. But the plot should come up as a separate screen for you folks to see. So that was one comparison. So you could see that between file 1 and file 2, the common words were actually different. And one was used much more often than the other in file 1, whereas file 2 was more of a gentler slope. And then we could change the different files that we're looking at. So if I edit configurations, I could look at 1997 compared to 1998. And we could see what happens there. So again, we just have to wait a couple minutes And then this is a new graph. So we see that, 1997 was closer in terms of word count to 1998 than it was to 2017. So some limits of my project were obviously that since I didn't use stemmers, my program is a little bit less precise than it should be. So using stemmers might have helped. My graph is still actually a little bit hard to read sometimes. The way that it looks, the words are overlapping. So maybe if I had made a table along with the graph, that would have been helpful. So those are two big limitations. I'm sure there are more that you folks could think of, but those are the two that come up in my mind. I could also maybe have done more graphs. So I could look at a whole, like an n number of graphs. I could look at a whole host of different texts compared to each other. So that also might have been useful. One interesting thing I learned was the difference between lemmatizers and stemming algorithms. I just didn't really know what the difference was, and I had actually never even heard of those words before. So that was really useful and really interesting to learn. So that's pretty much my project. Thank you for listening, and I hope it was useful.